everybody, Professor Rad here, and today we're going to talk about divisibility and prime numbers. So one of the things we're going to talk about first are little tricks that you can do to see if a number is a factor of another number or not. And then we're going to go ahead and figure out whether a number is prime or composite. So we'll define that in a little bit. So when you're looking for factors of numbers, here are some tricks that you can use instead of always having to, check every single number with your calculator. So the number itself and 1 are always factors of a number. So whenever you divide by 1, you get the number back again. So you don't have to check it. If you want to know, okay, is 1 a factor of 53? Yes, because 1 times 53 is 53. So those two are kind of free factors. You always get them. Then if a number is even, so being even, that means it ends in a 0, 2, 4, 6, or 8. So if it ends in any one of those numbers, that means that 2 is a factor. If it doesn't end in an even number or even digit, or if it's not even, if it's odd, then that means 2 is not a factor. So for example, 2 is a factor of 54 because it ends in 4, and 4 is even. 2 is not a factor of 53 because 3 is odd, and so 53 is odd. If a number ends in either 5 or 0, then 5 is a factor. If we think about when we count by 5s, we only get numbers that ends in 5s or 0s. 5, 10, 15, 20, 25, and so on. If a number ends in 0, then that means 10 is a factor. So 10, 20, 30, 40, and so on. Now this last one is kind of weird. It says if the sum of the digits is divisible by 3, then 3 is a factor. So this one's kind of weird, but what you do is if you add all the digits in the number, if 3 goes into that, then 3 goes into the original number. So for example, if I want to know is 3 a factor of 42, I could do 4 plus 2, which is 6. Since 3 goes into 6, yes, 3 is a factor of 42. To check for 31, 3 and 1 make 4. 3 doesn't go into 4, so no, 3 is not a factor of 31. If we want to check this real quick on a calculator, let's see if that last trick there worked. So we could do 42. Does 3 go in evenly? Yeah, it does. How about 31? Nope, we get a decimal. So we had the right idea there. So again, because you have your calculator, if you don't mind systematically checking every number, you can. But these are little shortcuts that can make it a little bit easier for you to do some mental arithmetic. Now, when we are looking at numbers and whether they're divisible by numbers or not, we're going to give them special names. So, a prime number is any natural number bigger than 1 whose only factors are 1 and itself. So as a reminder, we know that a number and 1 are always factors of a number, no matter what. So a prime number is a number whose only factors are those two, the number itself and 1. If a natural number larger than 1 is not prime, then we're going to say it's composite. Think about like composite materials or when something is composed of multiple things. Okay, that's what composite means here. A composite number is composed of multiple factors. So lots of different factors go into it. The number 1 is sort of the oddball. It's neither prime nor composite. So when we use prime numbers and composite numbers, we're only talking about numbers that are larger than 1. So let's apply some of these divisibility tricks that we talked about to see if we can figure out whether a list of numbers are prime or not. Okay, So let's determine whether each number below is prime or composite. So 16. I'm going to use my divisibility check for 2 here. I notice that 6 is an even number. So that means that 2 is a factor, which means that it's not prime. We have a factor other than 16 and 1, so this one is prime. Or composite. Oh my goodness. Sorry. So, because 2 is a factor, 16 is a composite number. Let's look at 13. So the check for 2 means 2 doesn't go into 13 because 3 is an odd number and 2 doesn't go into it. 5 isn't going to work because it doesn't end in a 5 or a 0. 10's not going to work because it doesn't end in 0. Let's try our trick for 3. So 3 plus 1 makes 4, and 3 doesn't go into 4, so 3 doesn't work. So I've used all of my tricks and I haven't found any. That doesn't mean that there isn't one that's going to work. It just means I'm going to have some technology help me. So let's go through and find our factors of 13. Well, we know 1 in itself are always going to work. We know 2 doesn't work. We know 3 doesn't work. What about 4? Nah, 4 doesn't work. Oh, good news. So we got a decimal that's smaller than 4, so we don't have to check anymore. Okay, so we checked all the numbers from 1 through 4. None of them work other than 1, which means 13 is a prime number. Okay, let's try 143. I'm going to rule out 2 because it ends in an odd number, and I'm going to rule out 5 and 10, again, because it doesn't end in a 5 or a 0. Let's try 3. So 1 and 4 is 5. 5 plus 3 is 8. 3 doesn't go into 8, so 3 won't go into 143. So we have to do the same thing we did with 13. So let's grab our calculator and see what we get. So 143. We know 1 works because it always does. 2 doesn't work, 3 doesn't work. Let's try 4. Nope. 5. Nope. So again, what we're looking for, we want whole numbers, not decimals. 143 divided by 6. No. 143 divided by 7. No. Let's try 8. Nope. And we still have to keep going because this number on the right is bigger than what we divided by. So we keep going till this number is smaller than what we divide by. Oops. Let's try. We know 10 won't work because it doesn't end in 0. So let's try 11. Oh my goodness. So it worked. 11 goes into 143 13 times. So that means that 143 is composite, since 11 times 13 is 143. Whew, okay, how about 55? I can tell 55 right away is composite. Which of my factoring tricks or my divisibility tricks is going to help me decide that? It's because it ends in 5. So 5 is a factor. And I happen to know that it's 5 times 11, but I could use my calculator to confirm if I wanted to. So when you are looking for factors of numbers or to figure out if a number is prime or composite, it can be helpful to know which numbers are prime. So I've listed out the first 20 prime numbers here. I'll be real, I usually remember up until about 31. And then I have to start like thinking, okay, it's 33, 35, 30, so, and at some point you start to check only the odds because even numbers, 2 is going to go into it. So these are the first 20 prime numbers. The more of them you recognize, the easier some factoring or divisibility stuff will be in the future. All right, and here are some now you try problems. So you're going to go through the process and figure out whether each of these numbers is prime or composite. You can use those divisibility tricks if you wish, But you can also work very methodically with your calculator, like we did when we listed factors before. In our next video, we're going to wrap up this section 4A by finding something called a prime factorization. And we're going to do a little gardening. We're going to make some trees. So I'm looking forward to seeing you in that one. In the meantime, have a magnificent day.